I'm just trying to remember. Hey, Matt.
Hey, Mike.
Would you like to do a podcast?
It's December, so yes.
Let's do it. And welcome to Hacking the Grepson. It's December something when you will listen to this.
Or next year.
Or next year, or whenever you listen to it. But right now, we are near the tail end of December. And on this podcast, at least for the last few years, that means we're talking about the...
Advent of Code.
Advent of Code! Yes, that wonderful annual tradition where Eric Wastel throws a bunch of crazy word problems at the internet and asks them to solve them.
He goes wastling, and a wastling we will go.
He wastles left, he wastles right. Make sure you keep track of those positions because you will need to process them later.
That's in part 2.
So, just in case you have never listened to one of our Advent of Code podcast episodes before, the Advent of Code is an advent calendar of programming puzzles or logic puzzles, however you want to look at them. There is a problem each day from December 1st to December 25th. Each problem has 2 parts. You get to part 1. If you solve it, you get to see part 2. Although each day a new problem comes out and you can tackle them in whatever order you want once they're released. You don't have to get 1 before you can go on 2 as long as it is day 2 of December. We talked about Everybody Codes before, and we alluded to Advent of Code. This is the big one. A lot of time and effort goes into this.
Not just by Eric Wastel, but by a lot of people who help him out, but also a lot of us who play it.
Yes.
Like the Slack channels at work are very abuzz about this. We have a whole Slack channel devoted to it that on our server.
Agreed.
There's a lot of talk.
It's...
My wife knows to just expect that I'm going to be in my office a lot for December.
Yeah, I let my wife know. She it's Advent of Code time, and at least in the very beginning of Advent of Code, where the puzzles are generally easier, they do generally get harder over time. Even I'm able to solve them. When they come out, as the time goes on, that gets harder and harder.
Yeah, generally speaking, part 1, especially in the early days, usually pretty doable. After that, like as the weeks go on, the part 1s become more difficult. And from the beginning, the part 2s are almost always like, oh, yeah, okay, now it gets tricky. Except for the first couple of days.
Right. Except for the first couple of days where both part 1 and 2 are, generally of somewhat equal difficulty.
When he's stress testing the server is what I'm guessing right. He's actually
doing.
He
just wants to make sure people can get to the website. I think part 1 definitely is more like, do you have a basic understanding of the situation that's being described in the word problem? And then part 2 is like, okay, do you really understand how to solve this? Because it usually involves some kind of optimization that you may or may not have done in the first part, or some edge cases that you weren't thinking about, or it's not always like a gotcha. It's not always like a weird twist, but it's generally requires more deep understanding of either the algorithm or the data structure or the whatever that the puzzle is often kind of trying to get you to think about and build in, either code or on paper, I guess, if you wanted to.
Yeah, we had an episode quite a while ago where we talked about different terms for people who code, right? Coder, programmer, software engineer, computer scientist, all that, and the slight differences. And I feel like definitely the early days are intended for anybody who codes should be able to do the first couple of days, maybe both parts of them. You could probably do part 1 of the next few. Right, but then it's okay, you actually program for a living, so now you're doing this. And then it starts getting into okay, you better at least be you better be doing software engineering, because you have to really think about making this robust. And then at the end, it's you have a doctoral thesis. You've done your doctorate in computer science, and maybe you've gotten them. It's how it feels. I don't have my doctorate or my master's in computer science, so I could be wrong, but it definitely gets computer science-y.
Yeah, well, and just for the record, like I don't think either you or I, despite now doing this is our fourth year that we've been doing this and covering it. I've gone back. I think we've both gone back to do some of the earlier years, but we started this in 2021, so this is now the fourth year we've done this, and neither of us have actually ever gotten through every puzzle in a year, right?
I'm actually going back and looking.
Okay.
I think 2021 is the closest I got. I got 2 stars on every day from 1 through 20, and then 1 star on 21, 22, 23, and 25. I did not get the one on my birthday that year.
That's really good. I forgot how well you did on that first year. That's awesome.
Yeah, that is the year when I did well. After that, there's like a clear drop off around day 15.
Now, would you say that that's because it got harder, or just you just didn't have the time in the subsequent years?
Both of those things.
Yeah. Okay.
Last year I was in Norway, so I was busy.
Yeah.
This year was very busy at work.
Yeah.
But it gets into the point where it's like, it's too hard and I'm not having fun doing it anymore. And then I stop.
There's definitely everybody has their kind of point where either it's asking you to do something that you're not familiar with, or it's simply just, even if you know what you're doing, it can be kind of a task to do it. And whether you have, I mean, that's something I ran into, like, regardless of whether I understood what to do, for me, especially like say day 7 on, it just takes me a long time to work through these things because I'm a web dev. I'm not doing data structures and, breadth first searches and memoization and 2D or 3D grid navigation process. I do not do this at any other time except Advent of Code. So every time it comes up, I feel rusty. And so it just takes a long time to do. And I just don't always have the time or the wherewithal to get into it. And it's sad because it's fun when I do, but I often don't.
I don't like dynamic programming problems in general. I just find them not fun to think about. And so that's usually when it starts getting to like, you need to do dynamic programming to do this, which is really just like solving a smaller case and caching it. Like
Right.
It's really all that is. And then like building up from there. It's usually working backwards. But as soon as it stops being like solving the problem and it starts being doing dynamic programming.
Yeah, like solving it
Like-
more optimally.
Yeah, I don't like that. I don't enjoy optimizing.
Yeah. It's sort of like, here's a jigsaw puzzle. Put it together at your leisure. Oh, okay, it took you a few hours. Okay, now do it again, but you only have 10 minutes. How could you possibly do this in a better way? So I think one of the more interesting things, just in sort of the longevity or the just how long most people last during a year. Advent of Code has a stats page, and so they show like the number of people that got like both parts gold star, 1 part silver, or no. Well, I guess they don't really keep track of the people who didn't get it. They only keep track of the people
Who didn't play at all.
Yeah, that would be, millions, billions of people. But on day 1 for this, for last year, and this year are very similar. So I'm just going to use last year because it's done. 252,000 people got 2 stars, and on day 1, and 86,000 ish got just 1 star. If you go to day 5, that number has dropped to 85,000 got gold, or the both parts, and only 33 got 1 part. And it just, except for a weird bump on day 6, it largely just keeps creeping down and down and down until on December 25th, we only have 12,000 people, down from 250,000 who got 2 stars. So if that doesn't say generally how it goes, I don't know what does, because if you look back at the other years, they all follow a very similar pattern.
I just went and looked at the 2 private leaderboards that I'm on. Mm-hmm. One is with you, and it's a much smaller one than the one for work. The one that we're on, I dropped off. You can tell I dropped off about day 14. I have like 1 other star after that, and at least 1 other person did that. The 2 like genius people that we know are both like gold stars all the way across.
Yeah.
Work one is very similar. I am the second to last person who didn't just like stop, from what I can tell. And the cutoff seems to be about day 14, day 14, day 15. So that seems to be where it's going this year,
Yeah.
at least anecdotally.
Yeah, and I think once we and we're obviously we're gonna go over each day's problems. On this episode, we're just gonna do like the first week, day 1 through 7. We're gonna spoil everything. Just warning. So if you haven't actually attempted these puzzles, you should before you listen to this, because you know, give it a shot. It's Advent of Code is super fun, and it's totally worth trying out. Even if you've never done it before, if this is like the first time you've ever heard of it, you should definitely try it before you listen to someone talk about the solutions. But we're going to get into full spoilers on everything, just FYI.
Indeed.
And with that, why don't we go to day 1 of Advent of Code 2024?
Do you want to do part 1s and I'll do part 2s from the descriptions?
That sounds great, because you definitely have more part 2s open than I do.
That's why I suggested.
All right. So day 1 of Advent of Code 2024 is called Historian Hysteria. As with every Advent of Code, it's Christmas themed, and it's generally you trying to help somebody related to Christmas make Christmas happen, and things happen that go wrong, and you have to fix problems that help people do this. I'll just read the first paragraph here. The chief historian is always present for the big Christmas sleigh launch, but nobody has seen him in months. Last anyone heard, he was visiting locations that are historically significant to the North Pole. A group of senior historians has asked you to accompany them as they check the places they think he was most likely to visit. So every day is a location, more or less, that you were looking for this chief historian.
To some extent, they get real weird. After a while.
I mean, they always...
When it starts out, you're just wandering around the North Pole with some historians looking for a guy.
Yeah. But yeah, and every year is sort of like this. It starts coherent, and then it kind of goes on a wild journey that doesn't necessarily make sense.
But it's fun.
But yeah, it's fun. And whatever gets you to the problems, because that's the meat of this. And so the first part of day 1 is, we'll jump down here where it says, upon pouring into the office, everyone confirms that the chief historian is indeed nowhere to be found. Instead, the elves discover an assortment of notes and lists of historically significant locations. This seems to be the planning the chief historian was doing before he left. Perhaps these notes can be used to determine which locations to search. So your puzzle input is just a list of numbers. Each line has 2 numbers on it with some spaces in between them. And it wants you to find so you're finding the distances between numbers in this one, right? So within each pair, they want you to figure out how far apart the 2 numbers are. And then you need to add up all those distances. So basically, like the first line is 3 and 4. And you need to find out the distance between that, which is essentially like subtract them, right? And get and the absolute value of it. So 3, if your numbers were 3 and 4, the difference is 1. And then you have another line with numbers and another line with numbers, and you just add up all those distances to get the answer.
Yep. And that's exactly what I did. Yeah. I created input from both lists, I sorted them, and then did a sum of the absolute value of the difference. Yes. I don't remember why I sorted them, but for some reason I decided that was important. Oh, because that's what you pair up the numbers and measure how far apart they are. Pair up the smallest number in the left with the smallest number in the right. So that's why I sorted them.
Right. Yes.
This one, the hardest challenge for me was my Python skills were rusty because I hadn't done Python since last Advent of Code.
Yeah, the first days are always like, oh right, like, I mean, just for the podcast listeners there, last year I started tracking all of my all of these days and my solutions and my notes and all that in a Ruby on Rails web app. So I continue to use that this year. And so I just go and make a new year, 2024. I add a new problem. So every time one comes out, I just fill out a form and put in my input and the samples, and then, run a script, and it runs all the samples and inputs with my code and spits it out.
And I do a very similar thing, but with zero website of it. It's all scripts and back end, and then Git, so I can store it. It exists, but I have no.
Oh yeah, because this was
nothing pretty.
This was the first year that you started tracking your solutions on a GitHub repo, right?
I have used it in the past. I definitely did it last year, but I've been more consistent about it this year. It's funny, if you go to my GitHub, you can tell I only do Advent of Code because it's like nothing all year and then a spike in December.
Exactly. Yeah. I mean, it looks like, yeah, I mean, you've been filling it out. You got at least up to day 18 in there, so that's cool.
Yeah, I don't think I've submitted the last few because they're just the description.
I mean, I'm not going to look through. I mean, you only have 40 commits, so I'm guessing that you're basically just doing one or two commits per puzzle. Just part one commit, part
It's
two
basically
commit.
when I get part one done, I commit it and push. And I'm like, and literally, I think my commit comment is part 1.1 complete. And then if I don't get them and I need to move on to another day, then it's like day 12 incomplete, and I push.
That is what that looks like. Yeah. So that was part one. What is the total distance between your lists? So yeah.
Yeah, very very straightforward, which as most day one part ones are.
Yes, and that's basically what I put in my notes. Is that I thought both parts were pretty straightforward. But that was part one. So what was part two, Matt?
So part two, our analysis only confirmed what the historians feared. The two lists of location IDs are indeed very different, which, obviously. So now they want to know how similar they are. So in this case, we go through and I think the similarity is you multiply the two numbers together. Basically, you get a product instead. Not a whole lot going on there. Mm-hmm. And you don't sort.
Right.
So that's basically the whole difference. And then you add up all those products and you're done. This is honestly easier than part one.
Yes. Yeah. Now that I'm re-looking at this, because there's no sorting. It's just frequency of a specific number, and then multiplying it.
Oh, that's what it was. Yeah, you take the number in the left times the number of times it shows up in the right.
Right.
Yeah. So I did that, and that was my solution. I wrote down for my part two, easy modification, don't sort, and do a multiply by count left to get the score.
Yeah. I would say that, I put easy by advent of code standards. Like, I thought, based on what I remember the other years being, this one was relatively straightforward. There was no gotchas. Part two was not harder, really. It was basically the same difficulty.
Yeah, it was can you read this problem?
Yeah. Which you got to give some easy ones in the beginning to get people in and think, yeah, I can do this, before you hit them with the insanity that comes later.
I feel like every few days there should be one that is just like, oh, I could do this.
Well,
I can knock this out in an hour.
Yeah. Well, and I think sometimes the difficulty does have little valleys like that, but it's never this easy again, really.
Yeah. No, this one was absolutely trivial.
Yeah.
Which is good. Like I said, he's stress testing the server.
Right.
Making sure that we have our templates all set up right.
Exactly. Which definitely most of my time was spent just like remembering how this web app works and figuring out how to run the thing again.
Exactly. So shockingly, the historian wasn't at the first location.
I know it's a huge twist, but they had to do it. So should we move on to day two? Day two is called Red-Nosed Reports. And it starts out with saying, fortunately, the first location the historians want to search isn't a long walk from the chief historian's office. So now we're moving away from the chief historian's office, trying to find him. We get a bunch of reports, the titular red-nosed reports, and they are, yet again, a set of lines of numbers.
Which is pretty typical for advent of code. It's either that or you get a grid.
Yeah. Well, and the reason that I assume that they do stuff like this way is because in the end you have to have an output that can be easily checked. And so the easiest thing to check is a number. And so no matter how crazy the puzzle is, like the answer has to be a number. It's very, very rarely not an integer of some sort, because that's the easiest thing to check on the end.
I think we actually did get a string earlier this, like late in the year this year, as opposed to just a number, which is I think honestly the first time I've seen that. In my past travels of previous years, there was one that actually wanted you to print out a set of numbers separated by commas. Yep, seen one of those.
So that's or maybe like an alphanumeric string, like if you're doing some kind of hashing or encryption thing. But in general, it's an integer.
So what are we trying to do with this one?
So we have this example report, which has lines of numbers, like 76421 is the first line of this sample report. And the engineers are trying to figure out which reports are safe. The red-nose reactor safety systems can only tolerate levels that are either gradually increasing or gradually decreasing. So a report only counts as safe if both of the following things are true. The levels are either all increasing or all decreasing. So that first line, 76421, would be safe on that point because it's all decreasing. And then the other rule is any two adjacent levels differ by at least 1 and at most 3. So they either have to be all going down or all going up, and any individual difference between a number has to be obviously at least 1, otherwise it's not changing. But it can't be changing more than 3, because that wouldn't be gradual. That would be sudden.
And you can't go up and down. You got to stay going in one direction.
So another line in this sample report that is not safe is something like 13245, because they're not all going up. We go up and then we go down and then back up again. And then the last one in the sample, 13679, is great because it's all going up except the difference between. Oh wait, no, that one is good. 3 and 6. Oh,
it goes up too high, if I remember correctly.
No, it's at most 3. The difference between 3 and 6 is 3. So I think that one's fine too. I'm trying to find one of these.
There's 2 safe ones. The first and the last one are safe, and all the other ones were unsafe.
Oh, right. The 97621, because it jumped down by 4. Yeah.
Right.
So this also seemed pretty simple. I think when I tried to attempt, oh no, that's not until part 2. Part 1 was very simple. Basically read in the numbers, loop through them, make sure that they're all either going down or going up. If they're not, immediately exit. And then also do a loop, I think, to check if the differences map out properly. I don't know. It's a brute force thing, but that's basically... Yeah. I wrote one method called isSafe, and it basically just checks them and is the line safe, and it passes it through and adds it to a list, and then I count up the length of that, is more or less what I did.
I'm looking at what I did, and I was smarter 20 days ago, apparently.
Oh?
I used a lot of XORs and knots, and I don't remember why.
What?
But basically, yeah. Oh, I remember why. So I go through the list, and I look for the max negative change and the max positive change.
Ah, nice.
As I'm going through. And then if either of them if both of them are 0, but one of them is not, or if both of them are if we got both a negative and a positive, or we got neither, so neither it increased nor decreased, or we got an increase and a decrease, I just return false immediately. Otherwise, I just make sure that the max negative charge and the max positive charge are within the range of 3. And then I just looped through that and summed it up.
I mean, it sounds like we did similar things, just... yours was, like I said, a little smarter in noticing what the pattern was, and mine was just more of a brute force, like literally go through the whole thing and check to see whether every I next to the I plus 1 matched the rule.
You probably figured out if it was increasing or decreasing by looking at the first 2 numbers, and then just kept going with that, checking the rule. And then for some reason I didn't do that. I don't know why I did it the way I did it. My thoughts that I wrote down was easy parsing. Hardest part was keeping my logic straight with all the knots and XORs.
Let's see. Yeah, the only note I put, I think I was trying to cleverly avoid using a loop through each index of the report, removing it and reevaluating. However, the way I did it, I needed to do that in the end. Thankfully, the numbers didn't get huge, so it was fine. A lot of these puzzles, especially in the early days, you can brute force them. And what that generally means is that something like this, where you need to check if the differences between all the numbers in a line match some rule, you can just go through each number and check it in a loop, as opposed to something like you did, which was a little more like pattern matching of the string or the list of numbers. Because if you add too many letters to the list, or the numbers get too big, or something like that, you can run into issues with the brute force method. You need to think more about what's the pattern going on here, which will come up again and again and again in these things, and is something I'm not good at, and is why I kind of noped out around day 7 as opposed to day 14. But we'll get there.
One thing I noticed is that I don't exit early from my loop unless there's no change. I go through the entire list unless there's no change between two numbers, because then I know it's not there before I do any of my checks. So it's probably a little bit less efficient, but also early days generally don't have to worry about efficiency. Part two, they threw a twist at, and this is actually fairly typical of Advent of Code. Like this type of twist is about what I expect. So the engineers are surprised that there's a low number of safe reports, and then they're like, "Oh yeah, we have a problem dampener." And basically, that magic module thing lets the reactor safety systems tolerate a single bad level in what would otherwise be a safe report. So there can be one bad level in there, and that doesn't mean that like, that one skipped by 3. And then that one goes to the next. It means just ignore that one, basically.
Just throw
Take it
one
out of the list outright.
Yep.
So it's like, if this one number wasn't in the list at all, would it be valid?
Yeah.
So this one, there were several ways that I could have approached it. I ultimately went with the inefficient one because I knew that that I could do it quickly, and that the data set, I looked at it, like I looked at the input, and it wasn't that bad. It was a small enough number where I'm like, it'll work. I don't have to bust my butt to try to make this like really efficient. My easy approach was basically to simply pop out each element in the list one at a time, check if it's safe using my previous method, and if not, then I put it back and try with the next one. And as soon as I found a safe, then I'm like, yay, it's safe. How about you? How'd you do this one?
Yeah, I'm sorry. When I was saying all that stuff about my notes, that was all about part 2, not part 1. I was trying to avoid doing an extra loop. I'm trying to remember. I'm looking at this like all I have is just. Oh right, in part 1, it's literally just go through each line, run it through this. Is it safe using the brute force method? In solution 2, it was basically the same thing. It was just what you said. Like take out one of the numbers. Run it through the same check. Is it now safe? Yay. If not, try it by popping out the next number and which is 2 loops now. And if I've learned anything from talking to you during this podcast, as soon as I'm putting a loop inside a loop, I feel bad. And I didn't used to feel that way, but now I have shame for doing that. But it still works.
And it's not bad. I did it too, but you just have to be aware of it.
Yeah.
Like, it's like, okay, wait, can I do this without doing that?
Right.
Do I need to worry about that? Is it a small enough data set where a quadratic run, complexity is fine? Yes, in this case, it was fine.
Yeah, and that's pretty much what happened. I was like, well, I don't like that I'm doing this, but I'm doing it, so here we go.
Yeah, and that is what I wrote in my notes.
Yeah, that's why. Thankfully, numbers didn't get huge or anything, so no problem running it. So.
How about day 3?
Day 3, mull it over. Okay.
Oh, this one.
So
I liked this one.
So yeah, this one was let's see. Let me reacquaint myself with it. It says part 1, initial thought, parsing.
And that was the difficult part of this one.
Yes. And also just as another note, with this web app where I'm keeping track of all of the puzzles and my solutions and my notes, I started tagging them to help me remind myself, like, what are the fundamental techniques that one needs to understand how to solve this problem. Now, the first tag that I came up with was string parsing. Now, literally every single one of these puzzles requires some amount of string parsing to pull an input in and look at it. So I didn't put that.
It's usually like split the line on some spaces or commas. Or something.
And if
especially
that's
early days.
If that's all, if that was really like, if there was nothing above that, then that's the tag it got. Otherwise, I tried not to overuse that tag because it seems a little obvious. But the only other tag I put on this one was regex. So I definitely spent a lot of time on regex. But the actual thing is, our computers are having issues, so I have no idea if we have any chief historians in stock. You're welcome to check the warehouse, though. And while you're there, you need to do some IT tech support.
Story of my life.
Yeah, so
it's like going to my parents.
It says the computer appears to be trying to run a program, but its memory, i.e. your puzzle input, which is several very, very long lines of quote-unquote corrupted data.
Yeah, it looks like gibberish to some extent.
Yeah.
With like some valid things in the middle.
Yeah. You know what it reminds me of? If you ever played Fallout 3 or New Vegas or 4,
yes.
The computer systems that you try to hack into are a similar thing where you're trying to find a valid string inside a bunch of nonsense like this. This is very much that.
Although that one is using basically mastermind rules to figure out if you got it right, and this one wasn't. It's a lot of multiplications, basically. It's what's in this one.
Basically, So you have these lines of what looks like nonsense, but they do have actual valid instructions in them. And the only one, at least in part 1, is MUL and then open parentheses and then 2 numbers separated by a comma. So it's basically like multiply these numbers together. And
that number is at most 999, if I remember correctly. Like you couldn't have
3-digit numbers.
You couldn't have any higher than 3 digits.
Right.
I didn't know if that would matter, but I put a check in for it.
The first thing I thought to do was, okay, we need a regex to carve out the valid, multiplication operations. And knowing how many digits are the maximum it could be does change your regex, because you don't know whether you're looking for 1 digit up to 12 digit, but thankfully it's only 3. And so the only issue I had with basically carving out these strings with the multiplications was I was accidentally replacing my array of multiplication operations as opposed to pushing new elements into it. So very, I mean, I don't know if that's a common mistake, but basically when you create an array that has a bunch that you're essentially using as like a tracker, like go through a bunch of stuff, and when you find something that's valid, add it to this array, and then get the length of that array or process the array later. You definitely want to add elements to it. You don't want to keep saying like your array equals the new thing, because basically it was only getting the very last thing at the end, and that threw me for a loop until I realized that I was doing that wrong. But that was, I think, the only issue I really had in the end with part 1, besides just figuring out the valid regex to run on it. What about you?
Parsing was, this was a parsing problem.
Yeah.
Like I said, I did regex as well. Mm-hmm. I don't think I ran into any particular problems. I did learn a new thing in regex, which I don't think I knew, which was that you can specify a range of how many of each instance of a match to return. So 1 to 3. I knew you could do like, give me 1 digit or 1 or more or 0 or more. Like I knew those, but I didn't realize that you could do a range. Which I did here, which was cool. But yeah, so I went through in parsing. I just found all the matches to my pattern, which was mul parenthesis 3 digits, comma 3 digits, and parenthesis, right? Mm-hmm. And then for each multiplication inside of that I found, I pulled out all of the integers using a regex because I already had one sitting right there, and then just multiplied them together. And then added that to my total. Pretty easy.
Yes. I would say part 1.
I like to play with the tools, especially in the early days.
I mean, shout out to regexer.com. I've been using that website forever. I know it's not the only one, but it's gotten better and better over time and is a very good way to check your regex. At least that's what I use. So,
Xer.
Like RE.
Oh, I've used this before. That's a good one.
Yeah.
I always forget to do that, and I just end up hacking away at a regex in my interpreter for a while until I'm like, that's the one I want.
Oh man, that website is invaluable, at least for me.
It would be the smart way for me to do it, but I do it I gotta learn way.
Yeah, I mean, sure, but I mean, you can learn using the website too, because it basically says, oh, this is a good one, and here's whether it matches or not. And if it doesn't, fiddle with it until it does, and then once it does start matching, it will give you details on like, here's what it's finding and why it's finding based on your regex and the grouping and et cetera, et cetera. So
cool.
Okay, so that
Did you do about the same thing for part 1?
I think so, yeah. It was just finding out that regex and then fixing that dumb mistake I had. But part 2, I really struggled on because the regex got harder and
they introduced conditionals basically. So you're still in the same corrupted memory, but now in addition to the multiplication statements, you also are looking for both the do instruction, which turns on future multiplication instructions, or a don't instruction, which disables future multiplication instructions. Mm-hmm. Otherwise, it's the same deal. It's just you have to pay attention to whether they're on or not. And I think I want to check this, that they changed something in the description since I read it.
Oh?
Nope, I guess not.
Oh.
I remember running into a problem with this one with the word don't in one of their examples, not having a apostrophe, and they said it worked. But it looks like I am either misremembering that or or they fixed it.
Ministry of Truth, man.
But I don't see it in my copies of the things. I did this one basically the same way, except I made a bigger regex that included searches for don't and do. That one's so a regex is really helpful for this kind of thing. So with the first one, it's not too bad. You could probably just like go through and never have to really look back. But do and don't both have the same first two letters, and so there's a possibility of you thinking there's a do that's actually a don't.
Right.
So it requires a little bit more checking. But if you're doing a regex, it's like okay, no problem. And then I just literally just go through the list, check the command. If it's a do, I turn on a flag. If it's don't, I turn off the flag. And then I add up whether or not I care about that multiplication. How about you?
Yes. Once I got past a dumb assumption on my part, which I think you actually helped clue me in on, is that I was assuming that each line, because there's, at least in the input, there's 6 lines. I thought that each line, because one of the things they say in the very beginning of even part 1 is that, or sorry, in part 2 is that the instructions start with an implicit do. So that means that like anything from the beginning on until you see a don't are good instructions. And I misinterpreted that to think that every line of the input had an implicit do, which of course was incorrect, and instead retained whatever the last line's last instruction was. And I went a long time before you clued me in on that misunderstanding and kept getting the wrong answer. So once I did that, and then also I made it easier on myself, and I took all lines and just concatenated them into one mega line, and then just ran my same regex on that, which I did need. I actually needed ChatGPT to help me with that, because it was, for me, it was not an easy regex to figure out. I mean, I use, regex sometimes, but in general, it's one of those kind of get it and forget it. I don't really like tinker with them much.
Oh, yeah.
And this one definitely needed some tinkering. And
it was a complicated one for sure.
Yeah. So, I mean, whenever I need that much help on something, at least in my web app, I put an asterisk. So I at least remind myself that this was one that I needed, significant outside help beyond Google searching or, just chatting amongst people. Like I actually needed either sample code or ChatGPT. I will say at this point, like however you feel about ChatGPT and LLMs to help with any problem, as far as programming goes, because there's so much of it out on the web that it's probably consumed at this point, it's pretty dang good. Like I think a year ago, people would have said that all the stuff that it spat out was total hallucinations. But at this point, like, it's kind of hard to ignore how useful it can be for something like this. Like, hey, I don't know exactly what the regex is to figure out how to get this out of this. Tell me what it is. And yeah, you could Google search forever to try to find that. But ChatGPT pretty much gave me the right one. It just, that was the misassumption I had about the do's and don'ts that got me. So
yeah, it was tricky if you don't account for that. If I remember correctly, because I just kept one list for the entire input, it didn't affect me.
Yeah.
Basically, I finished one line and then I parsed the next line and just kept adding to it.
Yeah.
And that made that not an issue for me.
Yeah. I think that's a good point about Advent of Code, is that the input, I have to stop myself from thinking that it's like this sacred text that I can't play with, because if I do, then somehow I'll get the wrong answer because I've messed with the sacred text. But sometimes you really need to massage the data they give you to make processing it easier. And so that's something to keep in mind when you're doing puzzles like this, at least for Advent of Code. So,
yeah. I found what the weird thing was with this one. It was that the samples changed. It wasn't that they have a do not in the original sample and a then, and they changed that to a don't and an undo or something like that in
Yeah.
the later ones. And I'm like, and the funny thing is, the original sample still works. Or like if you take the new sample and you put it in the first one, it works fine. Like as is, you get the right answer and everything. It's the same multiplication statements. So there's no reason for there to be multiple ones. But I wonder if like the apostrophe confused people or something, and so he took it out of part 1 so that it didn't screw up. Like because I know he beta tests all these things with people.
Yeah. I don't know. That's also a rare thing. They often use the same sample and just make the
I don't think I've ever seen it
harder.
change. I've seen sometimes they'll give you new ones. They're like, now try this. Or if like
Right.
the entire situation changes. But this one was just adding things. And it was like, well, but you can still use that one.
Yeah.
I actually really dislike when the sample changes because the way my code is written for my template, it always runs the sample and it always runs the input for both parts.
Yes.
Don't like it.
I agree. That's a large part of Advent of Code is reading the puzzle. Because at some point you're like, especially if you're one of those people who's running the leaderboards, you're just trying to figure this out as quickly as possible. So you're trying to filter out all of the non-puzzle data, all the fluff, but sometimes that makes you miss out on important things. So
Yeah, this is one of those things like people are bad at word problems in general.
yeah, well, because there's so much distraction.
always-
It's you have to interpret
I always
it.
did pretty well with them.
Yeah.
But these ones do have so much. They're so long that there's a lot of distraction that my ADHD kicks in, and I will just full on miss a line.
Yeah.
It's happened multiple times.
And it only gets more important to read it, and the descriptions only get
yeah.
longer and longer each day. It seems sometimes. So
Today's was ridiculous. But we're not going to talk about that.
no, we will talk about that eventually. Day 4, series search.
And that series, like the planet or the moon, rather,
Yes.
or the Greek god,
Not as
or
in
whatever series
a
is. I feel like some of
episodic
that-
set of
Yeah.
entities. So this one, I thought this one was kind of cute, and I thought part 2 was going to be harder, but I think part 2 might have actually been easier, or at least not.
That depends on how you solved it.
I don't know. Okay, so what we're looking at in day 4 is you get a grid of letters, and the only letters that are used in this grid are XMAS. So, the shortening of Christmas.
Oh man, I didn't even catch that.
It was right there the whole time. It's essentially a word search. It wants you to find the word Xmas in your grid of letters, be it, horizontal, vertical, forwards, backwards, even if it overlaps other parts. So it's
Diagonals.
a word search. And also it's the first day that we went from like a one-dimensional input to a two-dimensional input. So now we have to worry about, not just X, but Y and X, which is normal for Advent of Code. I think it came in maybe a little earlier than other years, but, if nothing else, all these years, another thing we should talk about is that over these years, you've probably been doing it as well, is creating libraries to use for all these problems. Like I have like a grid library that I can pull in that I've written that basically like given an input that has a two-dimensional text input like this will create a grid and then has methods that you can like, get what's at 3-4 or set 5-6 to something or find a specific character or, find the neighbors of all the things around a particular coordinate, that kind of stuff.
I actually got rid of my old grid class this year, and this was the problem where I rewrote it because it had gotten really cluttered.
Okay.
Last year, as I kept shoehorning in more and more functionality to make it work. And this year I was trying really hard not to do that. So I ended up making a new, simpler grid class this year.
Okay.
It didn't help that last year's basically was just, it printed it out pretty. And I was like, oh, that's not helpful. So this year it actually does stuff.
Oh, that's good. Because yeah, I mean, mine does both. I mean, it has like a show and tries to print it out nicely. And I mean, we'll get into some more. I added more functionality this year based on what the puzzles were asking. But this one is just, okay, so find the word Christmas or Xmas in a word search. And looking at my solution, I think the only issue that I had with this was I wasn't sure how to check diagonals in a grid. Somehow I was able to figure out the logic of, go through a grid vertically or horizontally and check for a specific string, essentially. But I wasn't sure how to do a diagonal. And so I did find an implementation of that on our good friend Stack Overflow, that takes in a two-dimensional array and gives you, the diagonals of it so that you can check to see whether, for instance, the string Xmas is in it. And then I just, ran the input through that and just counted up all the times that it found that string in all those different configurations and got the answer.
I so again created a new grid class, and I immediately added a new function to it called search from, which takes a coordinate and length and gives you all of the values in any direction from that thing until the end. And what I did is I looked for X's, and anytime I found an X, I just searched around it. I already had built into my position class, which I did keep from last year, the whole I used north, south, east, west, northeast, right? That coordinate system in my position just it makes it easier than saying up, down, and then up, right. So I can just say N, S, N, E, or whatever.
Yeah.
And so I just iterated over, found anything that had an X in it, or found any coordinate that had an X at it, and then just did that search, and then that was it. It was pretty straightforward. I very much brute forced it. I also thought this one was fun, mostly because I got to write a new class. So part 2 was not what I expected, I'll be honest.
Neither for
I don't
me,
know
nope.
what I expected, but it was not this, which was, we're not looking for the word XMAS, Xmas. We are looking for the word MAS, MAS, in an X pattern. So it's only diagonals now, and the A is shared between both MASes. Mosses?
I thought it was cute. I didn't expect it, but it was cute.
Yeah. My note literally is that is not where I thought part 2 was going to go. I thought we'd have to deal with wrapping around the edge of the grid. That's what I thought. I thought we were going to end up with the torus situation. The next thing was surprising. I subclassed my grid to what did I call it? An Xmas grid. And then I added a function called isX_mass that just basically picked I think I found all the A's, and then I checked the down right and the down left or whatever I used for that. From that in each direction, I got the 4 corners around it if it was an A, and then I checked to see if they were both MS if you sorted them. That was it.
See, and also my notes were no regex needed, part 2. I basically improved my grid class and used it to build a double loop checking for A, and then if it's northwest, northeast, southwest, and southeast neighbors match the right attributes. So
basically the same thing.
Yeah. So I love it when we come up with the same thing because that makes me feel so smart. Yeah. So I actually I was pleasantly surprised that part 2 was not as crazy, even though it seems like when they're describing it that it's crazier, but it really wasn't in practice.
It was more that it surprised me than anything else. I was like, huh. I always try to guess part 2 and I'm always wrong.
Well, I mean, that makes it good, right? Because if you could always guess it, then it wouldn't be super exciting.
Well, I try to write my code in part 1 to anticipate any changes that might come up in part 2, which is just good software engineering practice.
Yeah.
You're like, requirements will change. They do all the time. They do every day in this one. And so I try to at least account for it. This one was not a thing that I planned for at all.
Yeah, agreed. And on that,
Shall we move on to day 5?
On that note, day 5, print Q. Oh man, I did not.
It was easy. We just had to print the letter Q, and we were done.
I wish I could say that I had a a good time with this one, but I did not. And I wrote the this also has an asterisk because in the end for part 2, I was just like scouring the subreddit looking for someone else's solution to see why mine was wrong. But
That was for part 1 or part 2?
that was for part 2. For part 2. So part 1, what they want you to do, and my first note is, okay, the description has hit the, quote, oh man, I can't even get through it without my eyes glazing over, unquote, point. So this was the first time where the description was its own obstacle, because it was pretty long. And essentially what you get is an input of, essentially they want you to print stuff out, and they're giving you the instructions to print it out, which is and this is another thing that Advent of Code loves to do in their input, is that they'll have like some kind of rule set as the first chunk of the input, and then a blank line, and then a set of instructions or something that run with those rules. And so you get a bunch.
You got like rules and then input is the way I always think about it.
Right. And the ordering, so the rules are something like 47 pipe 53. And what that means is that the page 47 of this set of this document you're printing out needs to come before 53, right? And then the next one is like 97 pipe 13. So 97 has to come before 13. And then they give you a bunch of page numbers in each of these updates, each line of input that you're checking. And they're asking you yet again, which of these updates are correct in that they follow the rules. And if they do follow the rules and they're safe, then what's the middle number? Add up those numbers to get your answer. And so, when I first looked at this, I was like, ugh, I don't even want to deal with this. And then I went away, did my day, came back later, was able to get through it and understand it.
Now, Mike, do you look at these first thing in the morning? Do you look at them when they first come out at night? Because we're on the West Coast, so like 9 p.m. here is when they actually show up.
Right. It is very possible to read them and see them the quote-unquote day before they come out. So yes, in the beginning, I was reading them as they came out.
Yeah. This was the first one I did the night it came out as opposed to the next morning. I was being very intentional with not doing that this year because it eats up way too much of my time when I do that.
Yeah.
I'll work on it all night and the next day, and I don't want to do that. But this one, I maybe it was a Friday or something. I don't know. I was like, yeah, I'll look at it.
Yeah. I mean, it's always fun to look at and see like, okay, does this seem doable in my head? And for some reason it was not, but the next day I was able to look at it and interpret it. And I think as far as how I approached this in my code, let's double check on this. Solution 2 is a whole bunch of blops. Yeah. I think once again, it was just a simple function called violations, and it took in an order, which was like the second section of the input. So something like 75, 47, 61, 53, 29, and then goes through each of the rules and says, like, does it follow the rule? Like, are there any infractions, essentially? Are there any violations? And if there are, then it doesn't get counted. And if it's safe, once again, a safe report, then it gets added to an array. I find the middle number. I add up all the numbers. Yeah, like once I actually read it and grokked what they were asking, it wasn't that hard to get through. What about you?
Yeah. My first comment on this one was, this is either going to be trivial or a huge pain. We'll find out. It was somewhere in between. My initial approach was to make a map of page number to a list of dependencies, right? So you've got 74 or 75, 47 has to come before 53, and we know that 97 has to come before 47, so that means 97 has to come before 53. Like, I made that map as I went through. Basically, what would that be? The transitive property, I think. Basically made a transitive map, and then use that to determine if I can print a given page. Then I started going down the path of using sets, this is a great use for sets, because then you can make sure that you're not double including a page or whatever. Unfortunately, I realized about halfway through coding it that sets are great, but they don't keep order in Python anyway, right? So if you put a set together and you put in 1 and then 2 and then 3, it might keep it in 1, 2, 3 order when you go to pop them out, or it might reorder them.
So their hash dictionary is not arrays, basically.
Yeah.
Yeah.
Exactly.
Yeah.
So what I ended up doing a bunch of converting between types to get this to work. I did I finally had a good reason to use PyLint. So I don't know if we've talked about linters much on this podcast, but effectively, especially for interpreted languages like JavaScript, Python, all those, they go through and it does a lot of what a compiler would do back in the day, which is make sure your code is syntactically correct. Because I was getting really weird issues and I couldn't figure out what they were. And I ran it through PyLint and I was like, oh, okay. Because it was just, because it kept crashing.
What
And I
was
like,
the
I'm doing something
main
wrong.
issue that kept coming up?
I didn't write that down for some reason.
Oh, wow.
You'd think I would. I wrote down, I need to figure out how to, oh no, that's not what I just wrote. I figured out how to get, what was going wrong is all I wrote down. And then what I finally ended up doing was I ended up making a class. This is the first one I got to make a class for this year. Well, a custom class, I guess, which was Page. These are classes I make just to hold the information so I can think about it in my head. I got to learn a new operator overload function in Python called IAD, which is the plus equals. I had never overloaded that before. So basically, if I did a plus equals to Page, then I added all the dependencies for the other page number. That was how I built my list, was using that.
Huh.
And then the actual, and then I had a separate function altogether, which was like is correctly ordered, that took the pages and put them in the right order. It was very ugly. But ultimately I did a filter and then I rewrote all my code afterwards. Okay, I did it all and I used like not dependencies dot intersection set remaining. And then I was like, I could have used filter. So after I got the right answer and submitted it, I cleaned up all my code to use map and sum,
Nice.
which looked way nicer,
Yeah.
but was completely useless.
But it made you feel good, right?
Did it?
I mean, well, you love refactoring often feels.
I do. In fact, that'll come up a couple of times in this one.
Okay, so that was part one.
So just like, is it in the right order?
Yeah, is it in the right order? And then part two was definitely the kind of twist you might guess that they would do.
Yeah. This one, what they wanted to do was for each of the incorrectly ordered updates, they wanted us to use the page ordering rules to put the page numbers in the right order. Basically, was it. And then, you finding the answer based on the incorrect ones. So I immediately understood what needed to be done for this one. I'm like, great. But I was doing this one at night, and I went, nope, I'm tired, and didn't want to do it. In the morning, when I looked at it, I basically just did like a bubble sort algorithm to reorder the pipeline. And otherwise, I basically just reused everything from part one. Ugly code, but it worked. So I, in this one, do the same. I wrote a whole reorder pages function that like has a while loop and a for loop.
I also have a while loop with a map for loop.
And then that is wrapped. So first I have a filter to pull out the incorrectly ordered pages, which was basically just the reverse of what I did in part one. And then I sum the map, like the map function, not a dictionary, of an update function with that, basically to get with my reorder pages function. It was, like I said, ugly code, but it worked. Using maps, definitely. I've been trying to get better about using filter and map and like reduce, which I never use, but like those functions more, which I will credit TypeScript and JavaScript for actually encouraging me to do those because of how poorly they do loops. How'd you solve this one?
Yeah, no, well, as I said when we first started talking about this, I tried a lot of things and because once again, I'm a web dev by trade and not a data structure algorithm programmer. So even something as simple as like a bubble or insertion sort, like, which is what I ended up using to fix this, was just not coming to me because it's not something I really think about doing. And I found another person's Python solution and was able to use, because we didn't even mention what languages we were using this year. I'm using Ruby again, and you're using Python again, I assume. So yeah, Python won the day on this one, but I mean, it has nothing to do with it being Python. That's just the one I found that I grokked the best. But it was the same basic strategy that you did is that, break out all of the incorrectly ordered lines in the input and then essentially run them through while it's still quote unquote broke or incorrect, sort it using, I think mine actually uses an insertion sort, or maybe it's a bubble sort. I don't know.
They're very similar.
Yeah. Until it's in the right order and passes muster, essentially. It's just that I couldn't on my own figure out that that's what I needed to do in that way.
Also, two of the least efficient sorts.
Right. Well, and yeah,
but they're easy.
If this was day 20 or something, then, they probably wouldn't have worked and you needed to use something more optimized. But this was still day 5 and the numbers were small and the input was small. So this one got an asterisk. I spent way too much time trying to figure this out and it just was not coming to me. So boo on day 5 for me.
Boo.
Not boo earns, straight up boo. All right. Day 6. Guard Gallivant. Now, this one was one that I did not think that I was going to get because we're back in 2D land. We have a guard who is walking. Well, your input is basically a grid, and we have dots for spaces that he can move, and we have hash or octothorpes for obstacles that if he runs into, he changes direction. And I think in part 1, actually maybe both parts, if he hits an obstacle, then he turns to the right 90 degrees and then keeps walking in that direction. So the first thing that I had to do on this one is, once again, go back to my grid class that I've been using for any of these 2D puzzles and add the concept of a cursor. I had never done that. Apparently, none of the puzzles that I've solved thus far needed a cursor or and a character that actually moves in the grid that you keep track of, like independent of the other things that are in the grid. So I wrote some stuff so that my grid class could take that, and then I did a little loop to essentially go forward a move. So the cursor has a position, the cursor has a direction, and it's sort of a video game, and it's a very simple video game where your cursor or your avatar does not have, it moves one space per instant or per frame or whatever, and it moves in a direction, and the only time it changes its direction is if it hits an obstacle or if it's about to hit an obstacle. Yeah. And like I said, it turns. And so the question of part 1 is
how long until it goes off the map?
Yeah. So the grid has boundaries, obviously. It's you can and so you basically, I just basically simulated him moving through the grid until he went off the map, and I just counted up all the positions that he visited and got my answer. So that one was pretty easy. All the work was basically adding the cursor idea to my grid class and a way to track it. So, yeah. What about you?
So I did a brute force approach. I figured that seemed like the right approach for part 1, especially not knowing what part 2 was going to be. Mm-hmm. I'm like, it's not worth trying to guess that, so I didn't. I did similar to you. I have a grid cell class that is an extension of my position class. Mm-hmm. That is what my grid is made up of. Mm-hmm. That has a few more things like the character, like the grid. The position class doesn't have a character associated with it, like a string that shows what's in the position. But my grid cell one does. So I made a guard class that extended from that, and that one had I think he had like a walk function or something. Step. He had a step function that I just called iteratively. I did run into some weird problems with this one.
Okay.
I got really wrapped around the axle on order of operations when trying to handle the guard goes out of bounds case. And what ended up being the problem was that I was moving the guard, but because he was out of bounds, he ended up outside of my grid didn't handle it correctly because he was out of bounds. Mm-hmm. So I had to detect that he was going to go out of bounds. Mm-hmm.
Not just that he is now out of bounds.
Yeah, and so I had to remove him properly and at the right time. Because what I think I was doing is I was moving him and then removing him, and then that was leaving him in the old position or something. So I ended up putting a left behind thing if I move somebody and all sorts.
No
of
guards
fun
left behind,
stuff.
Matt.
Yeah. That's what I did. Yeah, as he moved, every step he took, I put an X in that spot. And when he left the grid, it wasn't adding that X because of the way it worked. Because he was no.
I like
Because I was swapping with nothing.
I like that. I mean, obviously you did this, but I'm still an OOP novice. But like adding the cursor to my grid class did the same thing that yours did, but it is now part of the grid class, and I'm running into that same issue that you ran into, where the grid class is just getting overloaded with all of these various things from all these different puzzles, as opposed to making additional classes that work in tandem. So I like that.
Yeah.
And if I were to go back through here and refactor, I would totally do that.
And a lot of the later problems that I haven't done yet involve multiple things moving around the grid.
Yeah.
And so having a cursor starts being a problem.
Yes,
You're
you're
but
right.
Being have multiple actors. I basically this is how I would write a game. So
Yeah, no, it's
that's
great.
what I did here.
I love it, and this is exactly why we do this kind of podcast, because that's how this stuff comes up.
Yeah.
So part 2.
Part 2 wasn't a huge change. It was the same deal, except you time traveled back in time so that you can get the guard's path, which I think you did in part 1 as well. But now we went back further and like store the information. Now you know the guard's path. And the historians decide, well, we can add one obstacle without breaking the space-time continuum. I think they just said paradox, but still.
Yes, they did.
So it wasn't just add one so that he gets stuck in a loop. It was add one, find all of the positions where you could add an obstacle that would cause the guard to get stuck in a loop.
Right.
That was, my note was, this seems like a headache. So I probably just immediately put it away. The only thing I could think of to solve it, like at least at first, was to implement loop detection, i.e. know when I've looped back around, when I've hit a part that I've already done in the direction I've already done it, which is basically memoizing, and then loop through each cell in the map and try to make an obstacle there and then run the guard through the whole thing. Very brute force. I wrote, there must be a more efficient way. And then I wrote, I think the only spots in the initial route marked with an X, except the starting position, are places where we can place an obstacle to make the loop, since otherwise it wouldn't have hit them. So I was able to reduce my problem space from the entire grid to just where the guard had walked.
Nice.
I don't know the gender of the guard.
Yeah.
So they. So I ended up just looking at those spots, and that made a big difference in how much time it took. And then my loop detection, I just kept a map of where the guard had been, including the direction he was facing.
Mm-hmm.
And if it repeats, I knew I had a loop.
Just as a side note, I was curious if they actually referred to the guard with a pronoun, and
I think they
they do, a she, actually.
Yeah, I thought I remembered that.
So what I wrote on this is I was like, okay, this is going to be one of those ones where, the numbers could get big, because I also brute forced it, and I wrote that my thought process: figure out what constitutes an infinite loop for the guard, and then figure out an efficient way of determining potential obstacle placements. And what I did in the end is that I did a similar thing where I was just trying to figure out, placing an obstacle, do they get into a loop or not? But also that I needed to keep checking. I needed to keep upping the number of iterations that I was checking for to see when it started to not change in the end. So I started with, okay, let's do 100 simulations, like 100 frames of him moving or her moving, and then 1,000, and then 10,000. And I was I was worried because that I thought eventually the brute force would not work and it would take too long. And it's still, in the end, I think I ended up with 100,000, which was enough to figure out whether they were stuck in an infinite loop. But it took like nearly 3 minutes, at least in Ruby, to run that. But I got the right answer.
That's not bad.
So it once again feels bad and feels wrong, and it violates the one directive that I think is the platonic ideal of an advent of code is that if I run my script on a particular day, it should output in, a second or two at most. And this one is the 1st one that violates that because, generally it, boop, there's the answer. And if it's taking longer than boop, then you're probably doing something wrong or you're not optimizing it. But you might still get the right answer.
So I actually had a couple of problems with part 2 of this one, of it taking too long. And the main reason turned out to be the way I was copying my entire grid so that I didn't screw up things.
Right.
And I was doing too deep of a copy. And so it was like, and I was doing it twice. And the way I found this out is I put a profiler into my code, and I actually made it so that instead of just running my code now, every day when I generate my template, it automatically adds the profiler to it and puts it and like outputs it to specific files so that I can look at the actual profile of where I'm spending all my time. Because I knew
that's awesome.
Once I hit this problem that I was going to start hitting it again.
Yeah.
So that was really cool. I enjoy Advent of Code primarily because it gives me an excuse to learn new things. And so I got to learn how the profiler worked better. Pretty happy with how that came out, and it's come in handy a couple other problems. But yeah, the copy operation I was just doing so many times that it was like it was like a 2 to the n problem instead of an n squared, right? Kind of an issue just because of the copies. So I found a much easier way to copy it, and that worked.
Yeah, the only thing that I've ever done, at least with Ruby, is just adding time before running the Ruby script, which is just a Unix.
Yeah, that's what I usually do.
But I mean that doesn't tell you a lot, except that either it should take almost no time or it's taking more than almost no time, and you need to fix it. But yeah, profile.
And now I get pretty pictures.
I'm sure Ruby has something like that. I've just never looked into it, but you've inspired me to look into that. That's cool.
Final day of this recording.
Yes, bridge repair. Okay, so from here on out, except for 1 or 2 days that I got the first one, this is where I really had trouble and was not able to get even part 1. But part 1 is another thing I wanted to note is that in the ASCII art for Advent of Code, every day when they release a puzzle and they put another line, so you can click on each day. Apparently this is like the 10-year anniversary or like the 10th time they've done it.
Oh, it's a 10.
It's a big 10. It's a big 10, yo.
I thought it was going to be a camel for a while. Then I'm like, it's a snake. But 2 days ago, I see now, like, okay, it's clearly a 10.
It's a 10. Well, and the reason I bring that up is it seems like a lot of these puzzles often have links in the puzzle description to previous Advent of Code days. I mean, they do that a lot in general.
This year specifically.
Yeah, I feel like they're putting, like, it's like every day is kind of somewhat inspired by some previous puzzle, which, is not uncommon, but yeah, they're really calling it out this year. So, bridge repair. There's a broken bridge. You got to repair it. And your puzzle input is you have lines of numbers. The first number is your target value, and then you have a list of numbers after a colon that need to be combined using mathematical operators. And the only two that they require you to try are the addition and the multiplication. So plus and
because the elephants are holding those
right.
signs.
Because elephants are holding them. I mean, yeah. Obviously, there's a lot of flavor text that we're kind of cutting through here because there's a lot of flavor text. But
just sometimes the flavor text is so bizarre. It makes sense if you know the original problems.
Yeah.
But like, I didn't jump into these, and I haven't gone back and done them. Until like 4 years ago. I've only done a couple of problems from before that.
Yeah.
And so I'm just like, what?
I mean, yeah, I got to give props to Eric or whoever he has helping him write the descriptions. Like they're always very imaginative. The lore of each puzzle is well done and definitely has effort put into it. But the meat of this problem is you have these values and you have these numbers that you need to combine using either addition or multiplication. And essentially you need to find out so the first one, like
calibration.
Yeah, the calibration result, which is what happens when you say, for example, 190 is the value and the two numbers you have are 10 and 19. So is there a combination of 10 and 19 and one of those mathematical operators that gets you 190. And there's only one. There's multiply. So 10 times 19 is 190 because 10 plus 19 is not. And in this case, also, they're eschewing precedence. So it's left to right. So it doesn't matter whether normal, PEMDAS rules would apply, where you might... I'm not sure it matters with add and multiply.
It does.
I think it's the same. It's not the same.
Multiply definitely.
You're right.
Multiply has precedence.
You're right. Multiply because the M in PEMDAS comes before the A and addition. Right.
It actually screws me up. It screwed me up a little bit.
Yeah.
When going through this, just because like my brain kept automatically doing it.
Yeah.
The correct way, and I'm like, no, that's not how this works.
Right. Yeah. So they're saying no. Specifically, evaluate from left to right, regardless of what the operator is. Regardless of PEMDAS, you do it left to right.
I was sure PEMDAS was going to be part 2.
Yeah.
I was sure that was going to be it.
Well, I haven't seen part 2 yet. Okay. All right. So
Oh, you didn't solve this one?
No, I didn't solve this one. I spent a lot of time on this one and did not solve it. And the problem with this one, I think, is right. So I think the way you're supposed to solve this is essentially you're trying to figure out there is a set of permutations of numbers and operators. So for 10 and 19 and plus and multiply, you can either add 10 and 19 or you can multiply 10 and 19. At least in the case of two numbers, and this is the thing, it definitely depends on how many numbers you have that you're trying to find the permutation. At least if you're doing this the permutation way, which is the way I did it. I didn't solve it because the input itself, I got the sample, but the input, the number, the count of numbers that you are trying to find this equation in go in the sample, the most number is 4. But the first one in the input, at least in mine, is 5 numbers. And as soon as you try to find the permutations of 5 numbers and all the operators that go between them is insanity. And it just...
Yeah, it's literally exponential growth.
And so and because I couldn't figure out the right way to do it, I never got past that point. And so that's where I'm stuck with even part 1. So why don't you tell me the right way to do it?
Well, I don't know what you're doing wrong.
Okay.
But I did recursion specifically so that I didn't have to deal with all the permutations. Mm-hmm. I didn't have to keep track of keeping up with all the permutations would be more accurate. I'm just like, the stack will deal with it for me. I don't have to think about it. It was slow, but not like super slow.
Like a few seconds slow or like a minute slow?
So I ended up, the result I ended up with was in less than half a second.
Yeah, that's fast.
But I think it started off not that way.
Okay.
So I ended up with a fairly efficient solution. Usually recursion is not super efficient. It happened to work out in this case. Mm-hmm. My base cases for my solve were if there's only one value that I need to look at, I return the value. Oh, if I have none, I return 0. If I have 1, I return that value. Otherwise, I take I made a dictionary that mapped the actual symbol like plus or times or whatever. Those were the only 2 in part 1, to lambda functions. And then I just return, so I look that up to get the operator that I need to use. And then I calculate it. That gives me my subtotal of the first part of it. Mm-hmm. And then I create a new instance of my class with a list that's 2 items shorter, and I run solve again. And I just kept doing that until it popped everything off. And that worked. And once I get an answer, then I return true, and I was like, yes, calibrated. So it wasn't super complicated. It was just if you're good with recursion, and recursion is how I think, then it was easy. I didn't do anything fancy with my object. In fact, my objects probably made this much less efficient, which happens a lot. It's like, I'm storing all this stuff. I don't need all this stuff, but it makes my life easier when I'm debugging.
Yeah, I was going deep into like creating, once again, ChatGPT helped me figure out alternate permutation methods, because I assumed that it was just making, it was looking up permutations that were not necessary. And so, and the normal array permutation method of Ruby, I didn't think let you put a filter in. So I was like writing other kinds of permutations that were putting filters in, like, hey, if it doesn't pass this rule, then don't figure it out. But it didn't matter. None of that. As soon as that first input line with the 5 numbers, it just doesn't work.
Are you permuting the actual numbers?
I'm permuting the numbers and the operators to get.
Oh, you don't need to change the order of the numbers. The numbers stay in the order that they are, and you are inserting operators in between them. So you only have to permute the number of operators in between, and there's a lot fewer numbers in there.
Oh my god!
So you're just
somehow I did not think about that.
Plus times plus times.
Oh well, that's helpful. I'm going to make a note about that. Yeah, you're right. That was the whole point, is that you didn't change the order of the numbers. I don't know why I thought that I had to figure out, like, not only 11 plus 6 times 16, but also 6 plus 16 times. Okay.
You were probably trying to work around the non-PEMDAS thing, which turned out not to be super.
All right.
Turned out to be easier that way. In fact, if we had to do PEMDAS, that would have made it difficult to do it the way I wanted to. Because then it's like, okay, I'm doing plus, and I have
all right.
parentheses here.
I will go back to that later and check that to see if that helps. But that's useful. Thank you for pointing that out.
Part 2.
Yes, what is part 2? So I can
Well, part 1, I made a bunch of boneheaded mistakes as I was going through it. So it actually took me a really long time to get it solved. Part 2, my note is literally easiest change to make part 2 work ever. Like, the difference between part 1 and part 2 was the way I wrote it, absolutely trivial. I added one operator to my operator dictionary, because that was what part 2 was. Part 2 added a concatenation operator, which used the double pipe as the symbol, which is, of course, or but not here. But otherwise, it was exactly the same thing.
Oh, you mean?
So it's like if you had 15 double pipe 6, it became 156.
Oh.
So now I had to iterate through 3 operators. So it made it slightly longer to run, but not significantly at all.
Okay. That's not that scary.
My first one ran in half a second. My second one ran in. Oh, it did take a lot longer. It took 18 seconds to finish.
Okay.
So it wasn't short.
Interesting.
I just added the concatenation operator to my map. Oh, and the trickiest bit to not break what I had done is I had to pass in the number of operators that were allowed in my solve, so that I only looked at plus times, because I still wanted it to work for the first part of the solution. I always try to not break my first solution as part of this, which honestly causes me more work.
I was saying you don't need to do that. That seems like...
But I like to.
Yeah. I mean, if you have the time and the wherewithal, by all means, but...
Yeah. All right.
Okay, well, that's the first week of Advent of Code 2024. We'll be back next time with the next week of problems. But for now, that wraps up this particular episode of Hacking the Grepson. If you want to hear more Advent of Code musings and spoilers, we've got the last 3 years ready to go for you at hackingthegrepson.com. And until we come back at you with the next set of puzzles, we now return you to your regularly scheduled lives already in progress.